Something happened on October 13th, 2025 that nobody was supposed to talk about yet. A signal. Not the kind you pick up on a radio telescope. Not the electromagnetic chatter we've been scanning the cosmos for since the 1960s. This was different. This was light, pulsing light from an object that doesn't belong to our solar system, following a pattern so precise, so mathematically elegant, that calling it coincidence feels intellectually dishonest. The sequence? 5 pulses, then 8, then 13. If those numbers mean something to you, if they're triggering a recognition somewhere in the back of your mind, then you understand why independent researchers are quietly losing sleep over this. And if they don't mean anything yet, stay with me, because by the end of this you're going to see the universe differently. The object is 3, I-Atlas, the third confirmed interstellar visitor to enter our solar system, and on that specific date, October 13th, as it hurtled toward its closest approach to the Sun, researcher David Sereda claims his team detected something extraordinary: optical pulses. Brief flashes of light in the visible spectrum, captured through a network of amateur telescopes coordinated across 3 continents. The intervals between these pulses weren't random. They followed the Fibonacci sequence, a mathematical pattern woven into the fabric of reality itself, appearing in everything from the spiral of galaxies to the arrangement of seeds in a sunflower. 5 seconds, 8 seconds, 13 seconds. 3 consecutive bursts of light, each one timed with a precision that natural astrophysical processes simply don't produce. Now, before you decide whether this is the most important discovery in human history or an elaborate misinterpretation of data, consider the date. October 13th. Not random. Not arbitrary. Exactly 108 years to the day after the miracle of the sun at Fatima, Portugal, when an estimated 70,000 people witnessed the sun appear to dance in the sky, change colors, and plunge toward Earth in a display that remains unexplained by mainstream science to this very day. 108 years. Another number that appears in sacred geometry, in astronomical cycles, in the architecture of meaning that some believe underlies physical reality. Coincidence? Maybe. But you and I both know that when coincidences start stacking up like this, when patterns emerge from chaos with this level of specificity, something deeper is usually at work. Here's what we know for certain. The data exists. It's circulating through amateur astronomy forums, shared quietly among researchers who understand that making bold claims without institutional backing is career suicide in the scientific community. The light curves show anomalies, 3 distinct peaks in brightness that don't match the expected behavior of cometary outgassing or rotational modulation. The timing intervals, when analyzed, produce ratios that converge on phi, the golden ratio, approximately 1.618, the same mathematical constant that governs growth patterns in nature, the proportions of the human body, the spiral arms of galaxies. This isn't just data. This is structure. This is information encoded in light. And this is the part that should make you sit up and pay attention. No major observatory has confirmed this. NASA hasn't issued a statement. The European Space Agency remains silent. The professional astronomical community, the institutions with the billion-dollar telescopes and the peer-reviewed journals, they're acting like nothing happened. Which raises the question that's probably already forming in your mind. If this detection is real, if we genuinely received a mathematically structured signal from an interstellar object on the anniversary of one of the most witnessed unexplained phenomena in modern history, why the silence? Why isn't this the biggest story in the world right now? There are 3 possibilities, and I want you to consider each one carefully, because your answer reveals something about how you see the universe and our place in it. First possibility: the detection is an artifact, equipment malfunction, observational error, pattern recognition in noise, which human brains are exquisitely designed to do. Our ancestors survived because they could spot patterns in rustling grass. That meant predator, so we're hardwired to find structure even when none exists. Maybe this is epiphonemia, the experience of seeing meaningful connections between unrelated things. Maybe we're so desperate to not be alone in this vast cold universe that we're conjuring intelligence from random fluctuations in brightness. Second possibility, the detection is real, but it's natural. 3. Atlas is extraordinarily active, ejecting massive amounts of water vapor and dust as solar radiation heats its surface. Comets are chaotic, violent objects when they approach the sun. Outbursts happen, jets form. Maybe, just maybe, the rotational period combined with specific outgassing events created a pattern that looks structured but is actually just the outcome of complex physical processes we don't fully understand yet. The universe is full of false patterns after all. We thought pulsars were alien beacons when we first detected them in 1967, before we realized they were rapidly rotating neutron stars. Maybe this is another case of extraordinary claim meets mundane explanation. But then there's the third possibility, and this is the one that keeps you up at night if you let yourself really consider it. What if it's real and it's intentional? What if an object from interstellar space, traveling for thousands or millions of years through the void between stars, chose October 13th, 2025, the 108th anniversary of an unexplained mass sighting of aerial phenomena, to pulse light in a sequence that any mathematically literate civilization would recognize as non-random? What if someone or something is using the Fibonacci sequence, the golden ratio, the mathematical language embedded in the structure of reality itself, to say we're here, we see you, and we want you to know this isn't an accident? That's the question, sitting at the center of this entire mystery. And before you dismiss it as science fiction or conspiracy theory, consider that the scientific search for extraterrestrial intelligence has been using this exact logic for decades. SETI researchers have long argued that mathematics is the universal language, that any technological civilization, no matter how alien their biology or culture, would understand prime numbers, would recognize the Fibonacci sequence, would use mathematical constants like pi and phi as a way to distinguish artificial signals from natural noise. If we were trying to signal another intelligence across the galaxy, we'd use math. So why wouldn't they? The data from October 13th is not peer-reviewed. It hasn't been published in Nature or Science or the Astrophysical Journal. David Sereda is not affiliated with a major university. The telescope network that captured these observations is amateur, cobbled together from backyard observatories and enthusiast equipment. In the world of professional science, that means this claim carries almost no weight. But in the world of discovery, of genuine breakthrough, sometimes the amateurs see what the professionals miss, precisely because they're not constrained by institutional caution, by the need to protect funding and reputation. Sometimes the people looking for wonder actually find it. So here's where we are. An interstellar object, confirmed real by every major observatory on Earth, passed through our inner solar system in late October 2025. On October 13th, as it approached perihelion, its closest point to the Sun, a network of amateur astronomers claims to have detected optical pulses following the Fibonacci sequence. The timing coincides with a historically significant date associated with unexplained aerial phenomena witnessed by tens of thousands of people. The mainstream scientific community has not confirmed the detection. The data exists, but is not verified. And you and I are watching this unfold in real time, trying to separate signal from noise, meaning from coincidence, hope from delusion. If these mysteries have you on edge, the way they have me, hit like and subscribe, because we're going to go deep into every aspect of this story. We're going to explore why the Fibonacci sequence matters, what optical signals actually are, whether natural processes could create this pattern, and what it would truly mean, if this detection is genuine. We're going to look at the Fatima connection, the mathematics of communication, and the politics of scientific announcement. And by the end, you're going to have enough information to make your own judgment about whether we're witnessing the most important moment in human history or another false alarm in our long, lonely search for company among the stars. But first, we need to understand what optical SETI actually is, because most people still think the search for extraterrestrial intelligence happens exclusively with radio telescopes, listening for beeps and boops across the electromagnetic spectrum. The truth is far more interesting, and it explains why detecting a light-based signal from 3i Atlas isn't just plausible, it's exactly what cutting-edge researchers have been searching for all along. When most people think about searching for alien civilizations, they picture the massive radio telescopes at Arecibo or the Allen Telescope Array, those giant dishes pointed at the stars, listening for that telltale pattern that would announce we're not alone. That image is burned into popular consciousness, thanks to decades of movies and documentaries. But while we were all focused on radio waves, a quiet revolution was happening in SETI research, and it changes everything about how we understand what happened on October 13th. Light. Visible light. Laser pulsars. This is the new frontier of interstellar communication, and it's not speculative science fiction. It's rigorous, peer-reviewed research being conducted at Harvard, Princeton, Berkeley, and research institutions around the world. The field is called optical SETI, and its basic premise is both simple and profound. If you were an advanced civilization trying to communicate across interstellar distances, you wouldn't necessarily use radio waves. You'd use lasers, and here's why that matters for understanding the 3i Atlas detection. Laser light is directional. Unlike radio waves that spread out in all directions, diluting their strength as they travel, a laser beam can be focused, aimed with precision across vast distances without significant dispersion. If you want to send a message to a specific star system, to a specific planet, laser communication is vastly more efficient than broadcasting radio in all directions. It's the difference between shouting into a crowded room and walking up to someone and speaking directly into their ear. More signal, less noise. Maximum efficiency. Bandwidth is the second advantage. Light carries information at rates that make radio look like smoke signals by comparison. A single laser pulse can encode terabits of data, far exceeding what's possible with radio transmission at similar power levels. If you're trying to send complex information across light years of space, if you want to transmit mathematics, images, instructions for building technology, cultural libraries, the complete archive of your civilization's knowledge, you use optical communication. It's not even close. Not even close. Light wins. And then there's the physics of interstellar space itself. Radio waves interact with charged particles, with magnetic fields, with the tenuous gas between stars. They get absorbed, refracted, scattered. But visible and near-infrared light, especially monochromatic laser light at specific wavelengths, can pierce through interstellar dust with remarkable efficiency. It's like the difference between trying to see through fog with your eyes versus using a tightly focused LED beam. Light cuts through. Light travels clean. Light arrives intact. So when optical SETI programs began in earnest in the late 1990s, they weren't chasing fantasy. They were following logic. They were asking if we're smart enough to figure out that lasers are superior for interstellar communication, wouldn't any technological civilization reach the same conclusion? The answer seemed obvious, and that's when institutions started building dedicated optical SETI detectors, instruments designed to catch brief flashes of laser light from distant stars, pulses that would last nanoseconds but carry unmistakable signatures of artificial origin. Harvard's optical SETI program has been operational since 1998. Their telescope continuously monitors stars for brief optical pulses, looking for transients that are far brighter than the background starlight for a fraction of a second. Princeton runs a similar program. So does Berkeley. These aren't fringe operations. This is mainstream astrobiology research, funded by NASA and private foundations, staffed by credentialed astrophysicists and published in major journals. The scientific community takes optical SETI seriously because the physics makes sense. Here's what they're looking for. Imagine you're observing a star, And suddenly, for 1 billionth of a second, its brightness increases by a factor of 10,000. Then it returns to normal. That's the signature of a powerful laser pulse. Natural astrophysical processes don't do that. Stars don't flash like camera strobes. Supernovae brighten over hours and days, not nanoseconds. Even the most violent stellar flares follow characteristic rise and decay curves that unfold over seconds or minutes. But a laser pulse is instantaneous. On offer, unmistakable. And if you detect multiple pulses with structured timing, if the intervals follow a mathematical pattern, then you're no longer talking about natural phenomena. You're talking about technology. Now, let's bring this back to 3I Atlas. It's not a star, it's a comet, an interstellar object reflecting sunlight, not emitting its own light. So how could it produce laser pulses? The answer depends on what you think 3I Atlas actually is. If it's just a chunk of ice and rock from another star system, then it can't generate laser light. It doesn't have an internal power source. It doesn't have technology. But if it's something else, if it contains artificial components, if it's a probe or a vessel or a communication relay sent by an intelligence that arose somewhere in the vast stellar neighborhood around our sun, then suddenly optical signaling makes perfect sense. This is where the detection claim gets interesting from a technological standpoint. David Serada's team wasn't looking for nanosecond laser pulses. They were analyzing longer duration brightness variations in the visible spectrum, changes that lasted seconds, not microseconds. These aren't the tight, coherent laser beams that Harvard's optical SETI searches for. They're broader, more like powerful searchlight flashes than focused laser communication. And that distinction matters because it suggests a different kind of technology, a different purpose. Think about it this way. If you're a civilization sending a probe through another solar system, and you want to announce your presence to any inhabitants who might be watching, you don't need nanosecond precision. You need visibility. You need something that even primitive telescopes can detect. You need optical signals that are obvious, unmistakable, impossible to miss. If anyone is paying attention, 5 seconds of brightness increase, 8 seconds, 13 seconds, long enough to measure with amateur equipment, structured enough to eliminate the possibility of coincidence. That's not a data transmission. That's a calling card. That's someone ringing the doorbell. And here's the truly fascinating part. We're already using this technology ourselves right now in our own solar system. NASA's Deep Space Optical Communications experiment, launched aboard the Psyche spacecraft in October 2023, successfully demonstrated laser communication between Earth and the spacecraft at distances of millions of miles. The test achieved data transmission rates far exceeding conventional radio systems. We proved that optical communication works for interplanetary distances. We proved it's reliable, efficient, and practical. So when we ask whether an interstellar visitor could use light-based signals to communicate, we're not speculating about alien super science. We're talking about technology we already possess, just scaled up to account for longer distances and more powerful energy sources. The skeptic in you, and there should be a skeptic in you, is probably asking why hasn't optical SETI detected anything from 3I Atlas? If this object is signaling, why didn't Harvard's program catch it? The answer is simple. They weren't looking at it. Optical SETI programs focus on stars, specifically stars that might harbor habitable planets. They're not monitoring comets, asteroids, or interstellar visitors. Their observation protocols are designed to catch signals from fixed positions in the sky, from objects light years away that sit still relative to our perspective. 3I Atlas is moving fast, following a hyperbolic trajectory through our inner solar system. It's not in the optical SETI catalogue. Nobody was watching it with instruments designed for laser pulse detection. Which means that if David Serada's detection is real, if those Fibonacci-timed optical pulses genuinely occurred, they were caught by accident, by amateurs. by people who were observing this interstellar object for its scientific interest, its brightness, its unusual activity, not because they expected it to communicate. And if there's one thing history teaches us about major discoveries, it's that they rarely happen where and when we expect them. Pulsars were discovered by a graduate student analyzing scruff in radio data. The cosmic microwave background was found by engineers troubleshooting antenna noise. Sometimes the universe reveals its secrets to those who aren't important enough to know they should be impossible. So here's where we stand. Optical SETI is real science with a solid theoretical foundation. Light-based communication is not only plausible but probable for advanced civilizations. We've already demonstrated the technology ourselves. The instruments capable of detecting optical signals exist, but weren't pointed at 3I Atlas during its passage. And an independent researcher claims to have captured structured optical pulses from this object using amateur equipment during a historically significant date. All the pieces are in place for this to be genuine. But all the pieces are also in place for this to be a mistake, a misinterpretation, or a natural phenomenon we don't yet fully understand. The question isn't whether optical communication is possible. The question is whether the specific pattern detected on October 13th, that 5-8-13 sequence, is what it appears to be. And to answer that, we need to understand why those particular numbers are so significant, why the Fibonacci sequence isn't just another mathematical curiosity, but potentially the most important pattern in the universe. 0, 1, 1, 2, 3, 5, 8, 13, 21, 34. Each number is the sum of the two before it. That's the Fibonacci sequence, and if you've never encountered it before, it probably sounds like arbitrary mathematics, just another pattern that mathematicians obsess over because they enjoy puzzles. But if you've studied nature, if you've looked closely at the world around you, then you know this sequence isn't arbitrary at all. It's fundamental. It's woven into the structure of reality so deeply that finding it in a signal from an interstellar object would be, without exaggeration, the most profound discovery in human history. Start with something simple, a sunflower. Look at the arrangement of seeds in the center of a mature sunflower head, and you'll see spirals, two sets of spirals actually, one curving clockwise, the other counterclockwise. Count the spirals in each direction. You'll get Fibonacci numbers, 55 spirals in one direction, 89 in the other, or 34 and 55, or 21 and 34. The exact count depends on the size of the flower, but the ratio is always Fibonacci numbers. Always. This isn't a quirk of sunflowers. It's the optimal packing arrangement for seeds. The configuration that allows the plant to fit the maximum number of seeds into the available space without leaving gaps. Evolution discovered Fibonacci because Fibonacci is mathematically efficient. Pine cones. Same pattern. The scales spiral around the cone in two directions, and the number of spirals follows Fibonacci numbers. Pineapples. Fibonacci. The arrangement of leaves around a stem, a phenomenon called phyllotaxis. Fibonacci, the branching patterns of trees, where each branch splits according to the sequence. Fibonacci, the proportions of the human body, the ratio of your forearm to your hand to your fingers. Fibonacci ratios, the spiral of a nautilus shell, the arms of spiral galaxies, the structure of hurricanes. Fibonacci, Fibonacci, Fibonacci. This sequence appears everywhere in nature because it's mathematically connected to the golden ratio, represented by the Greek letter phi, approximately 1.618. As Fibonacci numbers get larger, the ratio between consecutive numbers converges on phi. 13 divided by 8 is 1.625. 21 divided by 13 is 1.615. 34 divided by 21 is 1.619. The further you go in the sequence, the closer you get to phi, that irrational number that governs growth, proportion, aesthetic beauty, and apparently the architecture of the cosmos itself. Phi shows up in quantum mechanics, in the geometry of space-time, in the distribution of matter in the universe. It's not just a human observation, it's a physical constant, like the speed of light or Planck's constant. It's baked into the laws that govern how energy and matter behave. And because mathematics is universal, because 2 + 2 = 4, regardless of whether you're a human on Earth or a silicon-based intelligence, orbiting a red dwarf star 1,000 light-years away, the Fibonacci sequence and the golden ratio represent a language that transcends biology, culture, and evolutionary history. This is why SETI researchers have long argued that mathematical sequences are the ideal first contact message. You can't send language. You don't share culture. You have no common reference points. But you both understand mathematics. If you receive a signal that transmits prime numbers, 2, 3, 5, 7, 11, you know it's artificial. Natural processes don't produce prime number sequences. If you receive Fibonacci numbers, same conclusion. These patterns are too structured, too specific, too mathematically meaningful to arise from random astrophysical events. They're signatures of intelligence. Carl Sagan explored this concept in Contact, his novel about humanity's first detection of an alien signal. In the story, the aliens use prime numbers as their initial greeting, a mathematical handshake that announces we're here, we're intelligent, and we're using a language you'll recognize. That wasn't science fiction whimsy. That was Sagan, who spent his career working on real SETI research, extrapolating from actual protocols and discussions in the scientific community. If you're trying to signal another civilization, you use math. It's the only universal language we know. So when David Sereda claims that 3I Atlas pulsed light in a 5-8-13 sequence, he's not just reporting random numbers, he's reporting a Fibonacci sequence. He's reporting the mathematical pattern that describes growth in nature, the golden ratio in numerical form, the universal constant that any technological civilization would recognize as non-random. If this detection is real, if those numbers are accurate, then we're not talking about a vague anomaly or an ambiguous signal that could be interpreted multiple ways. We're talking about a clear, unambiguous mathematical message. But here's the critical question. Could nature produce this pattern by accident? Could the rotation of a comet, the timing of outgassing events, the interaction of solar radiation with surface ice, somehow create brightness variations that happen to follow Fibonacci timing? This is where we have to be brutally honest about probability in physics. Yes, coincidences happen. Yes, with millions of measurements and countless comets and asteroids, eventually you'll find patterns that look meaningful purely by chance. But the Fibonacci sequence isn't just any pattern. It's a specific, highly structured, mathematically significant sequence. The probability of random outgassing producing exactly 5, 8, and 13-second intervals in that order during a single observation period is astronomically low. Think about it probabilistically. If 3I Atlas were brightening randomly, you'd expect intervals of varying length with no particular mathematical relationship. Sometimes 2 seconds, sometimes 9, sometimes 15, scattered across a wide range. For the intervals to land precisely on consecutive Fibonacci numbers, you'd need extraordinary fine-tuning. It's like flipping a coin 50 times and having it come up heads every single time. Possible? Technically, yes. Likely? No. Indicative of something other than chance? Absolutely. Natural processes produce patterns, but they're usually symmetric or periodic or fractal, not sequential mathematical series. A rotating comet creates periodic brightness variations, meaning the pattern repeats with regular intervals. Fibonacci sequences don't repeat, they grow. Each number is larger than the last, following a specific mathematical rule. That's not how rotation works. That's not how outgassing works. That's how encoding information works. Here's another way to think about significance. If you were designing a probe, an autonomous vessel sent to explore other star systems and report back or leave calling cards for any intelligence you encounter, how would you announce your artificial nature? You couldn't use language. You couldn't use symbols that require cultural context. But you could use mathematics. You could pulse your engines or reflect sunlight or emit radiation in patterns that no natural object could produce. Prime numbers, Fibonacci sequence, pi encoded in binary, anything that requires computation, that demonstrates intentionality, that screams intelligence to anyone watching. This is why researchers like Sereda aren't just measuring brightness variations, they're looking for structure. And if that structure matches one of the most fundamental mathematical patterns in the universe, a pattern that governs everything from DNA helixes to galaxy formation, then you're looking at something that demands explanation. Either it's an extraordinary coincidence, a 1 in a billion alignment of random events that happen to produce Fibonacci timing during one of the most observed interstellar visits in history, or it's intentional. Someone, something, used the universal language of mathematics to signal this is not random, this is not natural, pay attention. The beauty of the Fibonacci sequence as a communication method is its scalability. You don't need complex equipment to detect it. You don't need supercomputers to recognize it. Any civilization with basic mathematics, any intelligence capable of counting and observing patterns, will identify Fibonacci numbers as significant. It's elegant. It's universal. It's exactly what you'd use if you wanted to be understood by intelligences at vastly different technological levels. A Bronze Age civilization that understands geometry could recognize it. A spacefaring civilization with quantum computers could recognize it. And a 21st century human with an amateur telescope and basic timing equipment could recognize it. Which brings us back to October 13th, 2025. 5 pulses, 8 pulses, 13 pulses, consecutive Fibonacci numbers, detected from an object that traveled through interstellar space for potentially millions of years. Arriving during a date that holds historical significance for unexplained aerial phenomena, the pieces fit together too neatly to ignore, but they're also too extraordinary to accept without scrutiny. We're standing at the edge of belief and skepticism, and the only way forward is to examine exactly what was detected, how it was measured, and whether the date itself adds meaning or just coincidence to an already improbable claim. Let's get specific. Let's talk about what David Sereda's team claims they actually observed, because details matter when you're evaluating whether something is the most important discovery in human history or an elaborate case of seeing what you want to see. On the night of October 13, 2025, a coordinated network of amateur telescopes spanning North America, Europe, and Australia was observing 3 IATLS. The object was approximately 1.2 astronomical units from the Sun, roughly the distance of Earth's orbit, approaching its perihelion scheduled for late October. It was bright. Magnitude 4 or 5. Visible to the naked eye from dark sky locations, which for an interstellar comet is exceptional. Most comets require binoculars or telescopes to see, but this one was putting on a show, ejecting massive plumes of water vapor and dust as solar heating vaporized its surface ice. Sereda's team was analyzing light curves, which are graphs showing an object's brightness over time. Standard astronomy technique. You point your telescope at a comet. You take multiple exposures over hours. You measure the brightness in each image. You plot it. Most of the time, you see gradual changes as the comet rotates, as different surface features face your direction, as outgassing activity waxes and wanes. It's usually smooth, continuous variation, but according to the data Sereda released, October 13th showed something different. 3 distinct peaks, sharp increases in brightness lasting approximately 5 seconds, 8 seconds, and 13 seconds, separated by periods of baseline brightness. The first pulse occurred at 2100 hours UTC. The second followed roughly 10 minutes later. The third came another 12 minutes after that. The timing of the pulses themselves, their duration, is what caught attention. 5 seconds, 8 seconds, 13 seconds, Fibonacci numbers. But here's the part that makes this harder to dismiss as coincidence. The intensity increases were significant. Not subtle 1 or 2% variations that could be noise in the data. These were 20 to 30% brightness increases, large enough to be unmistakable in the measurements. The data was captured using CCD cameras, charge-coupled devices that measure incoming photons with high sensitivity and precision. Multiple telescopes in the network recorded the same timing, which is crucial for ruling out local equipment malfunction. If one telescope sees an anomaly, it could be a technical glitch, a cosmic ray hitting the sensor, atmospheric distortion. But when 3 or 4 independent telescopes, thousands of miles apart using different equipment, all record brightness peaks at the same moment, you're looking at something real happening at the source, not an artifact of observation. But, and this is critical, NASA and professional observatories monitoring 3I Atlas during this period report no such anomaly. Their data shows normal cometary behavior, consistent with an active object approaching perihelion, but without structured pulses or unusual brightness variations. So we have a direct contradiction. Amateur networks claim detection. Professionals say nothing unusual occurred. Which brings us to the question, who's right and why the discrepancy? First, observational bias. Amateur astronomers looking for anomalies might interpret normal variations as significant, while professionals, trained to be conservative, might filter out the same data as within expected parameters. Human perception is powerfully influenced by expectation. If you're hoping to find a signal, you'll see patterns in noise. If you're expecting nothing, you'll overlook subtle anomalies. Both perspectives introduce bias. Second, equipment differences. Professional observatories use different instruments, different filters, different exposure times than amateur networks. It's possible that the pulses Cerrida's team detected were in a specific wavelength range or required specific observation parameters that professional equipment wasn't configured for during that window. Astronomy is full of cases where different instruments see different things because they're sensitive to different phenomena, not evidence of conspiracy, just evidence of instrumental limitations. Third, timing. Space is big. Observations happen continuously, but no telescope watches a single object 24/7. There are gaps, periods when an object is below the horizon or when telescopes are pointed elsewhere. If the pulses occurred during a gap in professional coverage, amateur networks might have caught something the big observatories missed simply because they weren't looking at that exact moment. It's not that the professionals are hiding data, it's that they didn't collect data during that specific window. Or fourth, the amateur detection is wrong. Misinterpretation of sensor noise, atmospheric effects creating apparent brightness changes, timing coincidences that look like Fibonacci numbers, but are actually random variations that happen to cluster around those values. This is the skeptical baseline, the null hypothesis. Extraordinary claims require extraordinary evidence, and a network of amateur telescopes claiming mathematical pulses that professional instruments didn't detect doesn't clear that bar. Not yet. But let's assume for a moment that the detection is real, that those pulses genuinely occurred and were correctly measured. Why October 13th? This is where the mystery deepens, where we move from astrophysics into synchronicity, numerology, and the question of whether the universe operates according to patterns we're only beginning to perceive. October 13th, 2025, is exactly 108 years after October 13th, 1917, the date of the miracle of the sun at Fatima, Portugal. For those unfamiliar with Fatima, here's the brief history. 3 shepherd children in a small Portuguese village claimed to see apparitions of the Virgin Mary on the 13th of each month, from May through October 1917. The final apparition, scheduled for October 13th, was supposed to include a sign, a miracle that would prove the visions were real. 70,000 people showed up. Skeptics, believers, journalists from Lisbon newspapers, curiosity seekers, and according to multiple independent accounts, including eyewitness testimonies and news reports from secular sources, something happened in the sky that day. The sun appeared to change colors: silver, yellow, red, blue. It spun, or seemed to spin, like a wheel, and then, most disturbingly, it appeared to plunge toward the earth, growing larger, radiating heat, before returning to its normal position. The event lasted approximately 10 minutes. Not everyone saw the exact same thing. Descriptions vary in detail, but the consensus is overwhelming. Something extraordinary occurred in the sky above Fatima on October 13, 1917, witnessed by tens of thousands, documented by skeptical journalists who had no religious motivation to fabricate the story. Explanations have ranged from mass hallucination to atmospheric optical phenomena like sundogs or light refraction through ice crystals. But none of these fully account for the specifics, the timing, the duration, the fact that people's clothes soaked by rain earlier in the day reportedly dried instantly during the event. Skeptics dismiss it as religious hysteria. Believers call it a miracle. Researchers interested in unexplained aerial phenomena note that the descriptions, the spinning disk, the radiating colors, the apparent descent, match patterns seen in other UAP encounters throughout history. And now, 108 years later to the day, an interstellar object allegedly emits light pulses following the Fibonacci sequence. 108, another number with significance. In Hindu and Buddhist traditions, there are 108 sacred texts, 108 names of deities, prayer malas with 108 beads. In astronomy, the distance from Earth to the Sun is approximately 108 times the Sun's diameter. The distance from Earth to the Moon is approximately 108 times the Moon's diameter. These ratios explain why we experience total solar eclipses, why the Moon perfectly covers the Sun during alignment, a cosmic coincidence that has no functional purpose, but creates one of the most profound visual experiences available to observers on Earth. Is any of this meaningful, or is it pattern-seeking? The same cognitive bias that makes us see faces in clouds and hear messages in static. The skeptical answer is clear. Coincidence? Humans are meaning-making machines? We find patterns because finding patterns kept our ancestors alive. The date is arbitrary. The Fatima event has natural explanations or is exaggerated in cultural memory. The 108-year gap is numerological nonsense with no physical significance. Occam's razor says the simplest explanation is usually correct, and the simplest explanation here is that Serrada's team misinterpreted data, saw Fibonacci numbers where none existed, and latched onto the October 13th date because it adds mystical weight to their claim. But the alternative answer, the one that keeps this mystery alive, is that synchronicity is real, that the universe operates according to deeper patterns than reductionist science acknowledges, that October 13th, 1917, and October 13th, 2025, are connected not by human interpretation, but by an intelligence that understands symbolism, that uses dates and numbers and mathematical sequences to communicate across time and space. That 3I Atlas didn't randomly pulse light in Fibonacci, timing on a historically significant date. It was timed. It was intentional. It was a message designed to be noticed by anyone paying attention to both astronomy and history. If you're spiritually inclined, this resonates deeply. If you believe the universe is conscious, that intelligence permeates reality, that contact between human and non-human consciousness happens through symbols and synchronicities, then October 13th makes perfect sense. It's not coincidence. It's communication in a language that transcends technology, a language of meaning, of archetypal significance, of numbers and dates that carry weight across cultures and centuries. If you're scientifically minded, this feels like motivated reasoning. You're taking unrelated events and forcing connections because the pattern is emotionally satisfying. The Fatima event has nothing to do with interstellar comets. Fibonacci numbers appear everywhere because they're mathematically common. The date is meaningless. You're building a cathedral of significance on a foundation of coincidence. Both perspectives are valid. Both contain truth. The question is which framework you use to interpret reality, and that choice reveals more about you than it does about 3 Ayat Ilas. Are you someone who sees the universe as mechanistic, governed solely by physical laws where meaning is a human projection onto an indifferent cosmos? Or are you someone who sees the universe as participatory, where consciousness and matter interact, where intelligence uses synchronicity and symbolism to bridge the gap between known and unknown? The October 13th detection, whether real or artifact, sits at the intersection of these worldviews. And before we can judge its validity, we need to understand the historical context it invokes, because Fatima isn't just a religious footnote. It's one of the most witnessed unexplained phenomena in modern history, and its connection to this story, whether coincidental or intentional, shapes how we interpret everything that follows. 70,000 people don't hallucinate the same thing at the same time. That's not how psychology works. Mass hysteria can explain shared emotional states, panic spreading through crowds, but it doesn't explain detailed, consistent reports of a specific visual phenomenon observed from multiple locations under varying conditions. Yet that's what happened on October 13th, 1917, in a muddy field outside Fatima, Portugal, and more than a century later, we still don't have a consensus explanation that satisfies both skeptics and witnesses. The accounts are remarkably consistent given the size of the crowd. The sun appeared to stop its normal movement across the sky. It began to rotate, to spin like a disc or wheel, flashing colors across the spectrum: gold, red, blue. Witnesses described it as dancing, pulsing, moving in ways that defied their understanding of celestial mechanics. And then came the terrifying part. The sun appeared to detach from its position and plunge toward the earth, growing larger, radiating intense heat that dried rain-soaked clothing and muddy ground in seconds. People screamed. Many fell to their knees, convinced they were witnessing the end of the world. And then, just as abruptly, the sun returned to its normal position and the event ended. Secular newspapers covered it. O Século, Lisbon's major daily, ran a front-page story describing the phenomenon without religious interpretation, focusing on the fact that something unexplained had occurred in front of a massive crowd. The reporter, Avelino de Almeida, had travelled to Fatima specifically to debunk the prophecy, to expose the children's visions as fraud or delusion. Instead, he found himself describing an event he couldn't explain, witnessed by engineers, doctors, farmers, educated urbanites, and illiterate villagers, all reporting the same core experience. Skeptical explanations focus on optical effects. Sundogs, atmospheric halos caused by ice crystals refracting sunlight, can create the appearance of multiple suns or coloured rings. But sundogs are static. They don't move. They don't plunge toward observers. Atmospheric refraction can distort the sun's appearance near the horizon, but the Fatima event occurred near midday when the sun was high in the sky. Retinal damage from staring at the sun can cause after images, spots of color, but that's an individual experience, not a shared observation of the sun itself changing behavior. Mass suggestion is another common explanation. The children had predicted a miracle for months. Tens of thousands arrived, expecting something extraordinary. Perhaps their expectations primed their perception, causing them to interpret normal solar appearance as miraculous. But this doesn't account for the physical effects, the drying of wet clothing, the sudden warmth reported by witnesses, the fact that people in nearby towns who hadn't travelled to Fatima and weren't part of the expectant crowd also reported seeing unusual solar activity that day. The most interesting aspect, from a modern perspective, is how closely the descriptions match other unexplained aerial phenomena: spinning disk, radiating colours, apparent movement toward observers followed by retreat, loss of normal celestial mechanics. If you remove the religious context, if you read the eyewitness accounts as purely observational data, they sound like descriptions of an unidentified object in the sky exhibiting unconventional flight characteristics. Not a miracle, not mass hallucination, an object. Which brings us to the hypothesis that some researchers have quietly entertained for decades. The Fatima event wasn't supernatural, and it wasn't psychological. It was a close encounter, An intelligence, using technology or capabilities we don't understand, created a visual display in the sky above Portugal on October 13, 1917. The children interpreted it through their religious framework as the Virgin Mary. The crowd interpreted it as divine miracle. But the actual phenomenon, the thing that happened in physical reality, was a demonstration of advanced technology appearing to a pre-technological society. This interpretation isn't mainstream. It's not accepted in academic circles. But it's not fringe conspiracy theory either. Researchers like Jacques Vallée, astronomer and computer scientist, have written extensively about Fatima as a potential UAP event, noting the parallels between witness descriptions and modern close encounter reports. The phenomenon didn't behave like a natural astronomical event. It behaved like a controlled demonstration, something designed to be seen, to be remembered, to anchor itself in cultural consciousness. And now, 108 years later, another anomaly. Not in the sky above Portugal, but in the darkness of space, from an object that doesn't belong to our solar system, an object that, if Sarita's detection is accurate, emitted light pulses on the anniversary of Fatima using a mathematical language that any scientifically literate civilization would recognize. 108 years. The same date. Another unexplained light phenomenon. Another event that sits at the boundary between natural explanation and intelligent design. You have to consider the possibility that these events are connected, not causally, not in the sense that 3I Atlas has anything to do with what happened in Portugal in 1917, but symbolically, in the sense that intelligence, whether human or non-human, terrestrial or extraterrestrial, operates through patterns that transcend linear time. That dates carry significance. That anniversaries matter. That if you're trying to get someone's attention, you don't just send a message, you embed it in context that multiplies its meaning. Think about how humans communicate importance. We don't schedule major announcements randomly. We use symbolism, anniversaries, significant dates. The Emancipation Proclamation was issued on January 1st, New Year's Day, symbolizing new beginning. The Declaration of Independence was adopted on July 4th, now a date that carries foundational meaning. When humans want to mark something as historically important, we anchor it to time in ways that future generations will remember. Now extend that logic to a non-human intelligence. If you're trying to communicate with a species across interstellar distances, you can't use their language. You can't reference their culture, but you can use mathematics, and you can use timing. If that species has a history of unexplained phenomena, if there's a date in their collective memory associated with unusual events in the sky, and you want to signal that this new event is related, you use that date. You create synchronicity. You turn coincidence into meaning. This is speculative, of course. It's untestable. You can't prove that two events separated by a century are intentionally connected. But you also can't prove they're not. And in the absence of proof, we're left with interpretation, with the choice between seeing the universe as random or as structured by intelligence that communicates through layers of meaning we're only beginning to recognize. The skeptic says, coincidence? October 13th is just a date. 1 out of 365. No more significant than any other. The fact that two unusual events occurred on the same date a century apart is mathematically unremarkable. With enough events, coincidences are inevitable. You're seeing patterns that don't exist, connecting dots that shouldn't be connected, because the narrative is emotionally compelling. The believer says, synchronicity. October 13th is significant precisely because it's been marked by unexplained phenomena. The universe is conscious. Intelligence communicates through symbol, through resonance, through the alignment of events that carry archetypal weight. 3I Atlas, pulsing Fibonacci light on the Fatima anniversary, isn't accident. It's message. It's contact happening in a language that transcends technology, speaking to those who pay attention to both science and mystery. Neither perspective can be definitively proven, but both shape how we interpret the data, how we evaluate Sarita's claims, And whether we see 3I Atlas as just another space rock or as something far stranger, something that challenges our assumptions about intelligence, communication, and our place in a universe that might be far more interconnected than mainstream science acknowledges. So where does that leave us? With an interstellar object confirmed real, approaching the Sun in late October 2025, with amateur astronomers claiming they detected mathematical light pulses on a historically significant date, with professional observatories reporting nothing unusual, with the Fibonacci sequence, the golden ratio, and 108 years of separation between two unexplained phenomena, and with a choice, dismiss it as coincidence and data artifact, or consider the possibility that we're witnessing something extraordinary, something that connects across time and space in ways we don't yet fully understand. But before we can make that choice responsibly, we need to examine the alternative explanations, because scientific integrity demands that we explore every natural possibility before we leap to extraordinary conclusions. Could 3I Atlas have produced Fibonacci-timed pulses through purely physical processes without any intelligence involved? That's the question we need to answer next, and the answer is more nuanced than you might expect. Science progresses by eliminating possibilities. You start with an observation, something anomalous, and you systematically work through every natural explanation you can conceive before you allow yourself to entertain extraordinary hypotheses. That's not skepticism for its own sake. That's intellectual discipline. It's the difference between discovering something genuine and chasing phantoms. So let's apply that discipline to the October 13th detection and ask, could a comet, even an interstellar one, produce light pulses that happen to follow the Fibonacci sequence without any intelligence involved? The answer, frustratingly, is maybe. Comets are chaotic objects. They're not uniform spheres rotating predictably. They're irregularly shaped chunks of ice, rock, and frozen volatiles that sublimate unevenly as they approach the Sun. Outgassing happens in jets, sudden violent eruptions of gas and dust from specific points on the surface where sunlight penetrates subsurface ice. These jets are unpredictable. They can flare up in seconds, persist for minutes or hours, then cease just as abruptly. And because the comet is rotating, because different surface features move into sunlight and shadow, brightness variations are constant. 3I Atlas is particularly active. Observations throughout its passage showed dramatic changes in brightness, dust production rates that varied by orders of magnitude, and a massive coma, the cloud of gas and dust surrounding the nucleus, extending millions of kilometers into space. This is not a quiet object. This is a comet violently shedding mass as it approaches perihelion, and that violence creates opportunities for unusual brightness patterns. Here's one scenario that could explain the detection without invoking intelligence. The comet is rotating with a period of several hours, which is typical for objects of this size. As it rotates, different patches of surface ice face the Sun and begin to sublime, creating jets. If the nucleus has three distinct active regions, three patches where outgassing occurs more vigorously than elsewhere, you'd see brightness peaks each time one of these regions rotates into sunlight. Depending on the comet's rotation rate and the distribution of active regions, the time intervals between peaks could vary, and with enough observations, some of those intervals might happen to cluster around Fibonacci-like values. How likely is that? Statistically speaking, not very. The Fibonacci sequence is specific: 5, 8, 13. For random outgassing to produce those intervals, you'd need extraordinary fine-tuning of rotation rate, active region distribution, and timing. It's not impossible, but it's improbable enough that most astrophysicists would flag it as requiring further investigation. Coincidences happen, but coincidences that produce mathematically significant patterns are rare enough to deserve scrutiny. Another natural explanation involves rotational modulation combined with precession. Precession is when a rotating object's axis wobbles, like a spinning top slowing down. If 3I Atlas is precessing while it rotates, the timing between brightness peaks could vary in a pattern that looks structured, but is actually just the outcome of complex rotational dynamics. Precession introduces periodicity at multiple timescales, and if those timescales happen to align with Fibonacci ratios, you'd see what looks like an intentional pattern emerging from purely mechanical motion. But here's the problem with that explanation. Precession is continuous. It creates gradual changes in timing, not discrete pulses separated by specific intervals. If precession were responsible, you'd expect to see a trend, a slow drift in interval lengths over multiple rotations. The October 13th detection, as described, shows 3 pulses with distinct Fibonacci timing in a single observation window. That's not consistent with precessional dynamics. That's consistent with discrete events, 3 separate outbursts or reflections timed with mathematical precision. What about fragmentation? Comets break apart. Stresses from outgassing, tidal forces from the sun's gravity, structural weaknesses in the nucleus, all can cause a comet to split into multiple pieces. If 3 Iatlas ejected fragments on October 13th, each fragment reflecting sunlight as it separated from the nucleus, you'd see brief brightness increases corresponding to each ejection event. And if 3 major fragments broke off in succession, the timing between ejections might appear to follow a pattern, again possible, but improbable. Fragmentation events are chaotic. They're driven by internal stresses and structural failure, not by mathematical timing. For 3 fragments to eject with intervals of 5, 8, and 13 seconds, you'd need the internal structure of the comet to fracture according to Fibonacci proportions, which has no physical basis. Materials don't fail according to mathematical sequences. They fail when stress exceeds strength, and that happens essentially randomly at the timescale of seconds. Here's the core issue. Natural astrophysical processes produce patterns, but those patterns are usually periodic, fractal, or power law distributions. Rotation creates periodic brightness changes, the same interval repeating over and over. Turbulence creates fractal patterns, self-similar structure at different scales. Avalanches and outbursts follow power law distributions, where small events are common and large events are rare, with frequency decreasing as a power of magnitude. Fibonacci sequences don't fit any of these categories. They're additive, they're deterministic. They require computation, either by an intelligence or by a physical process that implements mathematical rules. In nature, you find Fibonacci patterns in growth processes. Phyllotaxis, the arrangement of leaves and seeds, follows Fibonacci because growth occurs through iterative addition, each new structure adding to the sum of previous structures according to simple rules. But comets don't grow. They erode, they fragment. They don't add structure according to mathematical rules. They lose structure according to thermodynamics and gravity. So when you ask whether 3 Iatlas could naturally produce 5, 8, 13-second pulses without intelligence, the answer is yes, if you allow for extraordinary coincidence. But no, if you demand a plausible physical mechanism. There's no known cometary process that generates Fibonacci timing. There's no reason for outgassing, rotation, fragmentation, or any other natural phenomenon to follow that particular sequence. Which means one of 2 things is true. Either we're seeing pattern where none exists, a statistical fluke amplified by human bias, or we're seeing something that doesn't fit natural models. The scientific method at this point demands independent verification. If the detection is real, other observers should be able to confirm it. If it's artifact, repeated observations won't show the pattern. If it's natural but rare, we should be able to model it, to predict conditions under which comets produce Fibonacci-timed brightness variations, and then test those predictions. And if it's intelligent, we should see additional evidence, more signals, more structure, patterns that persist and elaborate as we continue to watch. As of now, we don't have that verification. We have one research team claiming detection. We have contradictory silence from professional observatories. We have a mathematically significant pattern that lacks a natural mechanism. And we have the Occam's razor problem. The simplest explanation is that the detection is wrong. that Serrada's team made an error in data analysis or interpretation, that the Fibonacci pattern is an illusion created by selectively filtering noise, but Occam's razor has limitations. It tells you that simpler explanations are more likely, but it doesn't tell you which explanation is actually true. History is full of cases where the simple explanation was wrong, and the complex, extraordinary explanation turned out to be correct. Continental drift was considered absurd until plate tectonics provided the mechanism. Meteorites were dismissed as folklore until we understood that rocks do fall from the sky. Bacterial origin of ulcers was ridiculed until Marshall and Warren proved Helicobacter pylori and won the Nobel Prize. The point isn't that every extraordinary claim is true. Most aren't. The point is that you can't dismiss extraordinary claims solely because they're extraordinary. You evaluate them based on evidence, on reproducibility, on whether they fit into broader patterns of observation and theory. And right now, the 3i Atlas detection doesn't fit cleanly into either category. It's not obviously false. It's not obviously true. It's ambiguous, sitting in that uncomfortable space where data exists but verification doesn't, where natural explanations seem strained but extraordinary explanations seem premature. What we need is more data. We need independent teams analyzing the same observation windows. We need rigorous statistical analysis to determine whether the Fibonacci pattern is significant or whether it's within the range of random variation you'd expect from an active comet. We need theoretical modeling to see if any plausible combination of rotation, outgassing, and surface features could produce those specific timing intervals. And we need continued observation as 3i Atlas moves toward perihelion to see if the pattern repeats, if more structure emerges, or if October 13th was a one-time anomaly that fades into observational noise. Until that happens, we're left with competing narratives. The skeptical narrative says this is a false positive, a case of pattern seeking in ambiguous data amplified by confirmation bias and the human need for significance. The alternative narrative says this is a genuine detection, a mathematically structured signal from an interstellar object, timed to coincide with a historically significant date, and the lack of professional confirmation is due to observational gaps, instrumental limitations, or institutional caution about announcing extraordinary findings without peer review. Both narratives are coherent. Both fit the available facts if you emphasize different pieces of evidence. Your choice between them reveals more about your epistemology, your standards for belief, than it does about 3i ads itself. And that's fine. That's how science progresses. Multiple hypotheses compete. Evidence accumulates. Eventually, one explanation wins because it accounts for more data with fewer assumptions. But while we wait for that resolution, there's another question worth asking. If the detection is real, if professional confirmation eventually emerges, why wasn't it announced immediately? Why the silence from major observatories? Why is this information circulating through amateur networks and niche research communities rather than dominating headlines worldwide? The answer to that question takes us into the politics of scientific discovery and the uncomfortable territory of institutional caution versus public transparency. If we genuinely received a mathematically structured signal from an interstellar object, if October 13, 2025 represents first contact with non-human intelligence, why are you hearing about it from an independent YouTube channel instead of from NASA, from the European Space Agency, from press conferences broadcast worldwide? That's not a rhetorical question. That's the question, and how you answer it determines whether you see this as a mystery wrapped in institutional caution or as evidence of deliberate suppression. Let's start with the most charitable interpretation. Scientific institutions are slow by design. Astronomy has been burned before by premature announcements that turned out to be false alarms. In 1967, Jocelyn Bell Burnell detected regular radio pulses from space with such precise timing that they were briefly designated LGM-1 for little green men. The possibility that this was artificial, that humans had detected alien technology, was seriously considered. until further analysis showed that the pulsars came from a rapidly rotating neutron star. A pulsar, a natural phenomenon no one had predicted but which made perfect sense once understood. False alarm. Embarrassment avoided only because the discovery wasn't prematurely announced as alien contact. In 2017, Oumuamua, the first confirmed interstellar object, generated massive speculation about artificial origin. Its unusual shape, elongated, like no known asteroid, its unexpected acceleration as it left the solar system, consistent with outgassing but unusual for an object that showed no visible coma. Harvard astronomer Avi Loeb proposed the possibility that Oumuamua could be artificial, a light sail or probe from another civilization, and that paper generated worldwide media coverage. Most astronomers rejected the hypothesis, arguing that natural explanations, while incomplete, were far more likely than alien technology. The episode divided the astronomical community and highlighted the tension between open speculation and scientific conservatism. Then there was the WOW signal in 1977, a strong narrowband radio signal detected by the Big Ear telescope that lasted 72 seconds and has never been explained or repeated. For decades, it was held up as potential evidence of extraterrestrial transmission. Recent research suggests it may have been caused by a passing comet ejecting hydrogen gas, a natural phenomenon, though that explanation remains contested. Again, the lesson: extraordinary signals don't always mean extraordinary sources. These experiences have made the professional astronomical community extremely cautious about announcing potential detections of alien intelligence. The peer review process is slow. Data must be verified, reproduced by independent teams, analyzed for every conceivable natural explanation before publication. That process takes months, often years. Immediate announcements don't happen because immediate announcements risk looking foolish if the claim falls apart under scrutiny. So one explanation for the silence around October 13th is that professional observatories did detect something. They're analyzing it quietly, and they won't say anything publicly until they're certain. This is standard procedure. Scientists don't announce discoveries via press conference. They present at conferences. They allow the peer review process to validate or refute their claims. If you detected what might be an artificial signal from 3i Atlas, you wouldn't tweet about it. You'd spend months checking your calibration, ruling out instrumental error, seeking independent confirmation. You'd be terrified of being wrong, of becoming the astronomer who cried alien and destroyed their credibility. That's the innocent explanation. It assumes institutions are doing their job, following protocols designed to protect scientific integrity. But there's another explanation, one that's harder to dismiss when you look at the history of how governments and scientific institutions handle information that might cause public disruption. What if the detection is real, verified by multiple observatories, and the silence is intentional? What if NASA, ESA, and other space agencies decided that announcing potential alien contact without full understanding of its implications would be irresponsible, panic-inducing, or contrary to national security interests? This isn't conspiracy theory. This is documented protocol. The SETI community has agreed upon procedures for handling verified detections, procedures that include informing governments before making public announcements, coordinating international response, and managing media to prevent misinformation and panic. The Rio scale, developed to quantify the significance of SETI detections, includes explicit guidance on public communication. Low significance detections, those likely to be false positives, aren't announced broadly. High significance detections trigger a multi-stage verification and announcement process involving international organizations. If 3i Atlas produced a signal evaluated as high significance, we wouldn't necessarily hear about it immediately. We'd hear about it when institutions decided we were ready to hear about it. And here's the uncomfortable part. You and I don't get to decide when we're ready. Institutions do. Governments do. Scientists and administrators who believe they understand the societal implications better than the general public. That's not inherently sinister. It's paternalistic. but it's rooted in a genuine belief that information must be managed to prevent harm. If you think announcing alien contact could trigger religious upheaval, economic panic, or geopolitical instability, you might decide that silence, or at least delay, is the ethical choice. But it also means that if a detection occurred, if verification is underway, we'd be the last to know. Amateur researchers like SETI, operating outside institutional structures, might leak information because they're not bound by the same communication protocols. They might decide that the public has a right to know, that transparency outweighs caution, that withholding this information is a form of control inconsistent with democratic principles. And that creates the exact situation we're seeing: unofficial claims circulating online, amateur networks sharing data, while official channels remain silent. Is that suppression? Or is it responsible scientific process? The answer depends on your trust in institutions, on whether you believe they act in public interest or in self-interest, on whether you think transparency is always the highest value, or whether sometimes maybe people in positions of knowledge legitimately need to manage how and when information is released. Personally, I find both perspectives compelling and troubling. The scientific process is designed to be slow, and that's usually good. Rushing to announce unverified claims damages credibility and spreads misinformation. But the process can also be used to delay indefinitely, to bury findings that are inconvenient, controversial, or paradigm-threatening. And in a world where governments have demonstrable histories of classifying information about aerial phenomena, about unidentified objects in our airspace and in space, it's not paranoia to ask whether the silence around October 13th is procedural or intentional. What would it take to break that silence? Independent verification from multiple sources. Amateur networks aren't bound by institutional caution. If enough independent observers confirm the Fibonacci pattern, if the data becomes so widely distributed that suppression is impossible, then official acknowledgement becomes inevitable, or, alternatively, continued observation. If 3I Atlas produces more signals as it approaches perihelion, if the pattern strengthens and elaborates, if what happened on October 13th turns out to be the first in a series of communications, then the story becomes too big to contain. We're in a waiting period. Data exists, but is contested. Claims have been made but not verified. Professional institutions are either analyzing quietly or dismissing entirely. And those of us paying attention are caught between hope that we're witnessing something historic and fear that we're participating in a collective delusion, seeing significance in noise because we desperately want the universe to be less empty than it appears. The truth, whatever it is, will emerge. It always does. Either the detection will be confirmed and we'll look back on October 2025 as the year everything changed, or it will be debunked and we'll move on to the next mystery, the next ambiguous signal, the next fleeting moment when coincidence looked like contact. Until then, we keep watching. We keep questioning. We keep demanding transparency from institutions that control access to the best instruments and the most complete data. Because if they're hiding something, if October 13th was real and we're being managed, then we have a right to know. And if they're not hiding anything, if this really is just amateur misinterpretation, amplified by wishful thinking, then we have a right to that truth too. Either way, transparency serves us better than silence. But to fully understand what's at stake, to grasp why this matters beyond the immediate question of whether SETI's detection is real, we need to understand what 3I Atlas actually is. Not just a comet, not just an interstellar visitor, but a messenger from deep time, from another star system, carrying information about places we may never reach and possibilities we're only beginning to imagine. Interstellar objects are extraordinarily rare. Think about the scale involved. Our solar system is one star among 400 billion in the Milky Way galaxy. The distances between stars are so vast that light, traveling at the ultimate speed limit of the universe, takes years to traverse them. The nearest star to the Sun, Proxima Centauri, is 4.24 light-years away, which translates to about 40 trillion kilometers, Objects ejected from other star systems have to travel those distances through interstellar space, through the near-perfect vacuum between stars to reach us. Most never do. They drift in the dark for billions of years, never encountering another planetary system, never being detected, silent and alone until the universe ends. 3I Atlas is different. It came from somewhere, from a star system we can't identify, ejected by gravitational interactions or stellar processes we can only theorize about. It traveled through space for millennia, maybe millions of years, until by chance, by the random walk of orbital mechanics, it entered our solar system's sphere of influence and was captured by the sun's gravity well, not permanently. Its trajectory is hyperbolic, meaning it's moving too fast to be bound to the sun. It came from interstellar space. It's making a single pass through our system, and it will leave again, continuing its journey into the void. We've only confirmed 3 interstellar objects so far. Theomorma, in 2017, discovered on its way out, already past its closest approach, traveling at such speed that detailed observation was impossible before it faded from view. 2I/Borisov in 2019, the first confirmed interstellar comet, which behaved exactly like solar system comets, proving that cometary processes are universal, and now 3I Atlas, detected earlier in its approach, giving us the unprecedented opportunity to study an interstellar visitor while it's still bright, still active, still close enough for meaningful observation. What makes 3I Atlas extraordinary even among this rare category is its activity level. It's bright, exceptionally bright for an object of its size. Most comets require telescopes to see. This one reached naked eye visibility, magnitude 4 or 5 at peak, brighter than many stars. That brightness comes from massive outgassing, water vapor and dust streaming off the nucleus as solar radiation sublimates surface ice. The coma, the cloud of gas surrounding the nucleus, grew to millions of kilometers in diameter. The tail, that iconic cometary feature, extended across significant portions of the sky. This level of activity tells us something about composition. 3I Atlas is rich in volatiles in ices that readily sublimate when heated. That suggests it formed in the outer regions of its home star system, in conditions similar to the Kuiper belt or Oort cloud, the distant reservoirs of comets in our own system. It's a fragment of planetary formation, a leftover from the era when its parent system was young, when planets were coalescing from the protoplanetary disk, and smaller bodies were being ejected through gravitational slingshots into interstellar space. Studying 3I Atlas gives us a window into those processes in another star system. We can analyze its spectrum, the light reflected and emitted, and determine its chemical composition. We can measure its trajectory and calculate where it came from, which region of the galaxy, which neighborhood of stars. We can watch how it behaves as it approaches the sun and compare that behavior to our own comets, learning whether cometary physics is truly universal or whether there are differences, subtle variations in composition or structure that reflect different formation environments. This is why professional astronomers were observing 3I Atlas throughout its passage, not because they expected it to communicate, because it's scientifically precious. It's material from another star system that came to us. We didn't have to build an interstellar probe and wait millennia for it to reach another star. The universe delivered a sample to our doorstep, and every observation, every spectrum, every image is data we can't get any other way. Perihelion, the closest approach to the sun, occurred in late October 2025. That's when the object was brightest, most active, most spectacular. It's also when it was most stressed. The intense solar radiation, the tidal forces from the sun's gravity, the thermal gradients between sunlit and shadowed surfaces all create enormous mechanical stress. This is when comets fragment, when they split apart, when their true nature is revealed, and it's the window when any signal, any intentional communication, would be most visible. October 13th fell, just days before perihelion. The object was already bright, already active, but not yet at peak. If you wanted to send a signal that would be detected by anyone watching, you'd time it for the approach, not the departure. You'd want maximum visibility, enough brightness for amateur equipment to capture, but not so much chaos that your signal drowns in noise. 5 days before perihelion. That's not random. That's strategic. Assuming, of course, that there was a signal. Assuming this isn't all projection, human narrative imposed on inanimate rock and ice. But even if 3I Atlas is just a comet, even if October 13th was a coincidence and the Fibonacci pattern was noise, the object itself remains extraordinary. It's a visitor from beyond. It came from a place we can't reach, carrying information about conditions in interstellar space, about the diversity of planetary systems, about the ubiquity of cometary processes across the galaxy. And here's the existential weight. This is our only chance. 3I Atlas will reach perihelion, swing around the sun, and head back into interstellar space on a trajectory that will carry it out of the solar system within months. We'll never see it again. It will travel for millions more years through the dark, perhaps encountering another star system, perhaps drifting forever through intergalactic space, cold and silent and alone. We have this brief window, these few months, to observe, to analyze, to wonder, and then it's gone. That finality adds urgency. If there's something to discover, we discover it now or never. If there's a message encoded in its behavior, we decode it before it vanishes beyond reach. If 3I Atlas represents contact, this is our moment to recognize it. Future generations won't have this opportunity. They'll study our data, our observations, and they'll either marvel at what we found or lament what we missed. So when David Sereda claims his team detected Fibonacci pulses on October 13th, he's not just reporting data. He's asking us to consider that this interstellar visitor might be more than rock and ice, might carry significance beyond its scientific value, might represent a moment that divides human history into before and after. And whether he's right or wrong, the question itself is worth asking. Because if we dismiss the possibility without serious investigation, if we let institutional caution or cynical skepticism prevent us from genuinely examining extraordinary claims, then we risk missing the most important discovery we could ever make. The universe is vast. Intelligence, if it exists elsewhere, is rare. The probability that an interstellar object carrying a signal would arrive during our brief window of technological competence, during the handful of decades when we have telescopes capable of detecting such things but haven't yet spread beyond our own planet, is vanishingly small. But vanishingly small isn't zero. And we're living in that narrow slice of history when it could happen, when we're watching the skies with eyes and instruments sophisticated enough to see, but still naive enough to be surprised. 3I Atlas is that surprise. Whether it's a comet or a messenger, whether October 13th was coincidence or contact, the object itself is a gift, a chance to touch the alien, to examine material from another world, to stand at the edge of the known and peer into the vast unknown beyond. And if it really did signal, if those Fibonacci pulses were real and intentional, then we need to ask, what would that mean? Not just scientifically, philosophically, existentially. What changes if we know we're not alone? What happens to human civilization, to our religions, our philosophies, our sense of self, when we confirm that intelligence arose elsewhere, that we share the universe with minds not born of Earth? That's the question waiting on the other side of verification, and it's the question we need to explore before we decide whether to believe Sereda's claim or dismiss it as another false alarm in our long search for cosmic companionship. Imagine for a moment that it's confirmed. Multiple observatories verify the detection. The Fibonacci pattern is real, repeatable, statistically significant beyond any reasonable doubt. October 13th, 2025 becomes the date humanity received first contact. Now what? What does it mean when an interstellar object communicates in mathematics? What's the message? And what do we do with it? The simplest interpretation is presence. The signal itself is the message we exist. We're here. We're intelligent enough to use a universal language, and we want you to know that your search for cosmic companionship has an answer. This is the most fundamental form of communication, the equivalent of saying hello, not a transmission of data or instructions, just acknowledgement. You're watching the stars. We see that you see, and we're letting you know you're not alone. That might seem underwhelming. We've spent decades imagining first contact as an encyclopedia of alien knowledge, as blueprints for interstellar travel or fusion power, as solutions to humanity's greatest challenges beamed to us by benevolent elders in the galactic community. But realistically, the first message probably wouldn't be complex. It would be simple, unambiguous, designed to be recognized as artificial by any observer, regardless of their technological level. Mathematics is that universal handshake, and Fibonacci numbers are mathematically significant enough to serve as greeting without requiring advanced decoding. But even a simple acknowledgement carries profound implications. If 3I Atlas signaled intentionally, then several things become true simultaneously. First, intelligence exists elsewhere, not just microbial life, not just bacteria in subsurface oceans on distant moons, but technological intelligence capable of interstellar engineering. That's the Copernican revolution multiplied by infinity. We're not the center of creation. We're not unique. We're one instance of a phenomenon that occurs throughout the universe. Second, that intelligence is active. This isn't a relic, a dead civilization's probe drifting through space long after its creators went extinct. This is a functioning system, something that detected our solar system, navigated to it or through it, and chose to communicate. That implies ongoing intention, ongoing decision-making. Somewhere, somehow, an intelligence decided that contact with Earth was worthwhile, and implemented that decision through technology we're only beginning to detect. Third, they're using interstellar objects as communication platforms. Think about the implications. Why would you send a signal from a comet instead of from a conventional spacecraft or a transmission from your home world? Because comets are inconspicuous, because they look natural, because they can travel for millions of years without raising suspicion, and only when they enter another star system, only when they're observed closely, do they reveal their artificial nature. It's elegant. It's strategic. It's the difference between knocking on someone's door and breaking it down. This suggests a level of sophistication that's almost unsettling. If 3I Atlas is a communication platform, it's been traveling for an incomprehensible duration. It didn't just leave its origin star system last year. It's been in transit for geological timescales, possibly longer than human civilization has existed. That means whoever sent it, whatever intelligence designed and launched it, either has patience beyond human comprehension or knew that communication across interstellar distances requires thinking in timescales of millennia or eons, and if they've sent one, they've likely sent many. 3I Atlas might be part of a network, a galaxy-wide distribution of probes disguised as natural objects, each one traveling through different regions of space, each one pre-programmed to signal when it detects signs of technological civilization. If you're a species interested in cataloging intelligence, in knowing where and when other minds arise in the galaxy, you wouldn't sit at home and listen passively. You'd send probes, millions of them, seeded throughout the galaxy, waiting, watching, reporting back, or leaving markers for those who notice. This is the Bracewell probe hypothesis, proposed by Ronald Bracewell in 1960. Instead of broadcasting radio signals in all directions, consuming enormous energy for messages that take centuries to reach their destinations, you send autonomous probes that can travel slowly, survey star systems up close, and communicate locally when they find intelligence. It's more efficient, more targeted, and it solves the problem of interstellar communication delay. If 3I Atlas is a Bracewell probe, then first contact isn't happening across light years. It's happening here in our solar system right now. But what's the purpose? Why contact us specifically, and why now? If these probes have been distributed throughout the galaxy for millions of years, they've presumably encountered countless civilizations at various stages of development, What makes humanity significant enough to warrant a signal? One possibility: we've crossed a threshold. We've developed technology capable of detecting interstellar objects, analyzing their light curves, recognizing mathematical patterns. We're no longer pre-technological. We're capable of receiving the message. And that's when the signal activates, when the probe determines that contact is feasible. Another possibility: this is a test. The signal is deliberately ambiguous, strong enough to be detected but not so obvious that it's unmistakable. It separates civilizations into categories: those who notice and investigate, and those who dismiss and ignore. How we respond reveals something about our nature, our curiosity, our willingness to engage with the unknown. If we pursue verification, if we treat this seriously and develop better instruments and protocols for future detections, we pass. If we shrug it off, if institutional inertia and skepticism prevent meaningful investigation, we fail, and the intelligence behind 3I ATLAs moves on, leaving us to our isolation. There's also the unsettling possibility. Warning: the Fatima connection, the October 13th timing, might not be celebratory, it might be cautionary. Both events, Fatima in 1917 and 3I Atlas in 2025, could be attempts by non-human intelligence to get our attention, to prepare us for something coming, something we need to understand before it arrives. The Fibonacci sequence, the golden ratio, could be the opening line of a longer message, one that we'd receive if we demonstrated the capability and willingness to listen. This veers into speculation, but speculation is all we have when dealing with intelligence so different from our own that its motivations are opaque. If contact is real, we're not negotiating with peers. We're encountering an intelligence that has mastered interstellar travel, that thinks in time frames of millions of years, that communicates through mathematics and synchronicity. Trying to infer intention is like an ant trying to understand why a human placed a sugar cube on the ground. The ant experiences the sugar. The ant might even recognize that the cube is too geometrically perfect to be natural. But the ant has no framework for comprehending human intention. We're the ants in this scenario. If 3I Atlas signaled, we'll spend decades, maybe centuries, trying to understand why, and we might never know. The message might be complete as delivered, proof of existence, invitation to join a community of minds scattered across the galaxy, or simply a data point in a survey so vast we can't conceive of its scope. What do we do with that? How does humanity respond if this detection is verified? The protocols exist. The International Academy of Astronautics has guidelines for announcing and responding to SETI detections. First, verify. Make sure the signal is real and not artifact or interference. Second, announce. Inform the global scientific community and, through appropriate channels, the public. Third, don't reply immediately. Any response should be coordinated internationally, representing humanity as a whole, not a single nation or organization. Fourth, study. Learn everything possible about the signal, the source, the implications. But protocols assume cooperation, and humanity doesn't cooperate well. If the United States verifies the detection, does it share that information with Russia, with China, with every nation regardless of geopolitical tensions? Or does first contact become another arena for competition, for national advantage, for the assertion that whoever understands the signal first controls the narrative and potentially the technology? And then there's the religious dimension. Every major faith would need to reconcile its cosmology with the existence of extraterrestrial intelligence. Some traditions already have frameworks for this. Islam references God creating beings on other worlds. Buddhism's cosmology is vast and inclusive, but others, particularly certain Christian traditions that place humanity at the center of divine attention, would face theological crisis. Not insurmountable, but disruptive. You'd see schisms, reformations, new interpretations of ancient texts. Religion wouldn't disappear, but it would transform, adapt, or fracture under the weight of confirmed contact. Economically, the impact is harder to predict. Does the knowledge that we're not alone change anything about stock markets, trade, resource allocation? Maybe not immediately. But long term, if contact leads to technological exchange, if we learn principles of physics or engineering from studying how 3i Atlas operates, that could revolutionize energy production, transportation, communication. That could obsolete entire industries and create new ones. That could shift global power structures as dramatically as the Industrial Revolution or the Information Age. Philosophically, existentially, the change is profound. The Great Silence, the Fermi Paradox, the haunting question of why we haven't detected alien civilizations despite the vastness of the universe gets answered. We're not alone, and we never were. The universe is inhabited, intelligence is common, or at least not unique to Earth, and suddenly every decision humanity makes, every choice about our future, happens in a context larger than ourselves. We're not just shaping our own destiny, we're participating in a cosmos, populated by minds, by civilizations, by intelligences with their own histories and purposes. That's what's at stake, if the October 13th detection is real. Not just a scientific curiosity, not just a data point for astronomers to publish and debate. A transformation of human self-understanding, as fundamental as any event in our history. And that's why verification matters so much, why we can't afford to dismiss this casually or accept it credulously. We need to know, we need certainty, because the implications are too vast to navigate based on ambiguous evidence and contested claims. So where are we now, as 3i Atlas continues its journey toward perihelion and beyond? Caught between extraordinary claim and extraordinary skepticism, between hope and doubt, between a universe that's empty and one that's full of silent watchers waiting for us to notice them. The only way forward is through rigorous investigation, through demanding better data, through refusing to accept easy answers, whether those answers are believer or skeptic, contact or coincidence. And ultimately, through understanding that the search itself, the act of looking and questioning and wondering, is what makes us human, what drives us to build telescopes and analyze light curves and imagine ourselves in conversation with minds not born of Earth. Whether 3i Atlas signaled or not, we're signaling. We're announcing our presence through our curiosity, through our refusal to accept that the universe is silent, through our insistence that there must be more, somewhere waiting to be found. So here we are at the end of this deep dive, and the question remains, did 3i Atlas communicate with us on October 13th, 2025? Did an interstellar visitor pulse light in the Fibonacci sequence on the anniversary of the Fatima miracle? Or are we witnessing the latest chapter in humanity's long history of mistaking noise for signal, coincidence for meaning, and our own desperate hope for cosmic companionship for actual contact? Let's review what we know with certainty. 3i Atlas is real. It's an interstellar object, the third confirmed visitor from beyond our solar system, traveling on a hyperbolic trajectory that brought it through our inner solar system in late October 2025. Its composition appears consistent with comets, rich in water ice and volatile compounds that sublimate dramatically when heated by the sun. It's extraordinarily bright and active, producing a massive coma and tail visible to amateur astronomers worldwide. Perihelion occurred in late October, after which the object began its long journey back into interstellar space, never to return. These are facts. They're verified by every major observatory. They're published in peer-reviewed literature. They're not in dispute. Now, let's examine what's contested. On October 13th, 2025, researcher David Sereda claims his network of amateur telescopes detected optical pulses from 3i Atlas, with timing intervals of 5, 8, and 13 seconds, corresponding to consecutive Fibonacci numbers. The detection has not been confirmed by professional observatories. NASA has made no official statement. The European Space Agency has offered no verification. The data exists in amateur networks but hasn't been published in peer-reviewed journals or independently replicated by institutional observers. This is where belief diverges from evidence, where interpretation matters more than raw data. because the data itself is ambiguous. Serada's team has light curves showing brightness variations. Those variations have been measured and timed. The question is whether those measurements represent genuine optical pulses from the object or artifacts of observation, atmospheric effects, instrumental noise, or selective analysis that emphasizes patterns while ignoring contradictory data. From a strict scientific standpoint, the default position is skepticism. Extraordinary claims require extraordinary evidence. Carl Sagan's razor. And this claim is as extraordinary as they come. Interstellar object transmits mathematical signal on historically significant date. The evidence as it stands is not extraordinary. It's contested, unverified, published outside traditional channels by scientific standards. This detection remains unproven. But scientific standards aren't the only lens through which to evaluate unusual phenomena. History teaches us that breakthrough discoveries often happen outside institutional frameworks, that amateurs sometimes see what professionals miss, that anomalies dismissed by mainstream science occasionally turn out to be revolutionary. Continental drift was ridiculed before becoming foundational geology. Ball lightning was folklore before being confirmed by physics. Meteorites were considered impossible until they weren't, so we can't dismiss Serada's claims solely because it lacks institutional backing. We have to evaluate it on its own merits, on the quality of the data, the plausibility of alternative explanations, and the coherence of the extraordinary hypothesis itself. The strongest argument against the detection is the lack of independent confirmation. If 3-eye Atlas pulsed light in a Fibonacci sequence visible to amateur telescopes, professional observatories with vastly superior instruments should have detected it too. The fact that they didn't, or at least haven't reported such detection, strongly suggests that what Sereda observed was local to his equipment or observation conditions, not a property of the object itself. This is the Occam's razor conclusion: instrument artifact or observational error, not alien communication. The timing argument, the October 13th Fatima connection, adds intrigue but not evidential weight. Humans are pattern seekers. We find significance in dates, in anniversaries, in numerical coincidences. 108 years between two unusual events is interesting narratively, but proves nothing scientifically, without physical mechanism connecting them. The coincidence is just that coincidence. Statistically, with enough events over enough time, such alignments are inevitable. The Fibonacci sequence itself is compelling mathematically, but its appearance in 3 brief pulses isn't sufficient to rule out natural causes. Comets are chaotic systems. Outgassing events are unpredictable. With continuous observation over weeks or months, you'd expect to see thousands of brightness variations, and within those thousands, some will cluster around mathematically significant intervals purely by chance. If Sereda observed 3-eye Atlas for hours on October 13th and extracted 5-8-13 from a larger dataset of varying intervals, that's selection bias, not detection. But the strongest argument against the skeptical position is the specificity. 8-13. Consecutive Fibonacci numbers, not approximate. Not close. Exact. According to Sereda's published timing analysis, the probability of 3 random events producing those specific intervals in that specific order during a single observation window is low. Not impossible, but low enough to warrant investigation rather than dismissal. And then there's the observational coverage issue. Professional telescopes don't watch objects continuously. They have observing schedules, time allocation, competing priorities. If the pulses occurred during a gap in professional coverage, during a period when major observatories weren't actively imaging 3-eye Atlas, then the absence of institutional confirmation doesn't invalidate amateur detection. It just means amateurs happen to be looking when professionals weren't. This is where we need more data, and frustratingly, we may never get it. 3-eye Atlas is moving away. It's already past perihelion, already fading as it exits the inner solar system. The window for close observation is closing. If the detection was real and was a one-time signal, we missed our chance to verify it with additional observation. If it was artifact, the lack of additional detection supports that interpretation. Either way, the ambiguity remains. So what's a reasonable conclusion? If you demand institutional confirmation and peer-reviewed publication before accepting extraordinary claims, then the October 13th detection is unproven and should be treated as speculative pending verification that likely won't come. If you allow for the possibility that breakthrough observations sometimes originate outside traditional structures and that absence of professional confirmation doesn't equal absence of phenomenon, then the detection remains plausible and worthy of ongoing investigation despite its contested status. My personal position, for what it's worth, is cautious openness. I don't think we have sufficient evidence to declare this confirmed contact. The lack of independent verification is a serious problem, but I also don't think we can dismiss it as definitively debunked. The data exists. The mathematical pattern is specific. The timing is provocative. And history has enough cases of premature dismissal that I'm wary of applying Occam's razor so strictly that we cut away genuine anomalies along with false positives. What I am certain of is that we need better protocols for this kind of situation. We need coordinated observation networks that include both professional and amateur astronomers, so that when anomalies are detected by one group, the other can immediately attempt verification. We need transparent data sharing, so that claims can be evaluated by the broader community without waiting for slow peer review processes. And we need a cultural shift in how we handle extraordinary claims, finding a middle path between knee-jerk belief and reflexive skepticism. Because here's the reality: if extraterrestrial intelligence exists, if contact is possible, the first detection might look exactly like this. Ambiguous, contested, detected by someone outside mainstream institutions who doesn't have the credibility to force official response. The signal itself might be subtle, designed to be noticeable to those paying attention, but deniable to those who aren't. And if we've structured our evaluation protocols so conservatively that only unambiguous, institutionally confirmed detections are taken seriously, then we might miss genuine contact simply because it doesn't arrive in the format we expect. The Fermi paradox asks, if the universe is full of intelligent civilizations, where is everybody? Why haven't we detected them? One answer, the one implicit in our current SETI strategies, is that we haven't looked in the right ways or the right places yet. But another answer is that we have detected them multiple times and we've dismissed every detection as artifact or coincidence or insufficient evidence. Maybe the universe is full of calling cards, subtle signals designed not to overwhelm but to invite, and we're so focused on unambiguous broadcasts that we're missing the whispers. 3i Atlas might be a whisper. It might also be nothing. Just wind in the data, pattern imposed on noise by human hope and imagination. I don't know which, neither does anyone else, not definitively. What I know is that the question matters, that the search is worth conducting, and that however this specific case resolves, we're living in an era when genuine contact is possible for the first time in human history. We have the instruments. We have the mathematical frameworks. We have the global communication networks to share data instantly. We have everything we need to detect extraterrestrial intelligence if it's out there, and if it's signaling. What we lack is certainty about what such a signal would look like, how it would arrive, and whether we'd recognize it when it appeared. October 13th, 2025 might have been that moment, or it might have been another false alarm in a long series of false alarms stretching back to the wow signal and before. Either way, we keep searching, we keep observing, we keep building better telescopes, developing more sensitive instruments, training our minds to recognize patterns without succumbing to pattern-seeking bias. And we keep asking the question, are we alone? Because that question drives us. It's driven us to build civilizations, to develop science, to launch spacecraft beyond our planet and peer ever deeper into the cosmos. The need to know whether we're unique or common, whether intelligence is Earth-specific or universal, whether the universe is a dead expanse or a garden of minds, that need is fundamental to who we are. 3i Atlas gave us a chance to answer that question, at least potentially. Whether the answer was delivered or not, whether we received contact or imagined it, the object itself remains a messenger from the deep, a visitor from beyond carrying information about the diversity of the universe and the possibilities inherent in existence. As it fades from view, heading back into the interstellar dark from which it came, we're left with data, with debate, with competing interpretations and passionate arguments. That's how science works. That's how discovery unfolds. Not through sudden revelation, but through gradual accumulation of evidence, through testing and challenging and refining hypotheses until truth emerges from uncertainty. Maybe 3i Atlas communicated. Maybe it didn't, but we communicated. Through our observations, our analyses, our willingness to consider extraordinary possibilities. We announced our presence to the universe, not through radio broadcasts, but through the simple act of paying attention, of noticing an interstellar visitor, and wondering if it noticed us too. And if there's intelligence out there, if the galaxy is populated by minds scattered among the stars, they'll know we're here because we're curious. Because we build telescopes. Because we analyze light curves looking for patterns. Because we don't accept silence as final answer. That's the real message, regardless of what 3i Atlas did or didn't transmit. We're here, we're watching, and we're not giving up on the possibility that somewhere, in the vast dark between the stars, someone is watching back, waiting for the moment when we're ready to receive what they've been patiently sending all along. If these mysteries have you on edge the way they have me, hit subscribe and stay tuned, because the story isn't over. 3i Atlas is still visible, still observable for a few more weeks before it fades beyond reach. More data will emerge. More analyses will be published. And the debate over October 13th will continue. In academic journals and amateur forums, in observatories and backyard telescopes, wherever humans gather to ask the oldest question we know: what's out there, and does it know we exist? Tell me in the comments where you're watching from, what time it is there, and whether you think we're getting the whole truth, or just the version they want us to believe. Share this on X, on Facebook, with anyone who wonders whether we're alone. Because this conversation, this collective search for meaning in ambiguous data, is how we move forward together into a future that might finally answer the question that's haunted us since we first looked up at the night sky and wondered if the stars were looking back.